Hi everyone, this is Kona, and I'm going to talk about Chapter 2, Hypothesis Testing. So Chapter 2, Hypothesis Testing, to start out with, is about claims. And a claim is just a statistical hypothesis about a population parameter. A good example of a claim is what you guys have already found for your first project. So those claims that you found where you had an actual percentage, and then you had, like a certain percentage of people thought this or did this, that would be your statistical claim. So it's normally part of the information given in a question, but the claim can either be a null or an alternative hypothesis, which we'll get into in just a minute. What determines whether the claim is a null or alternative hypothesis is whether the claim uses the less than or equal to, or greater than and equal to. If you use those, then the null hypothesis is the claim. If you use the less than sign, the not equal to sign, or the greater than sign, then the alternative hypothesis is the claim. And K is just a claim value for whatever that is. So the big thing here is making sure you realize this is a less than or equal to sign, equal to, and then a greater than or equal to sign, and that's the null. And then you've got a less than, a not equal to, or a greater than are the alternative. So in stating a hypothesis, the null hypothesis, which is H naught or HO, contains equality. So pronounced H sub 0 or H naught. The null hypothesis only uses these types of symbols. So it might not actually have that symbol in the claim, but if you read it out loud, there will be something that implies that it's less than or equal to, greater than or equal to, or equal to something. The alternative hypothesis, which is H sub A, or just the alternative, is something that means no equality. So its alternative hypothesis only uses the less than symbol, not equal to symbol, or greater than symbol. So to scroll down a little bit more, here are the three different hypothesis options for one sample hypothesis testing. So you've got mu, which is your mean, is less than or equal to the claim value, and then that's your null. And then your alternative, which is kind of the flip side, is your mean is greater than your claim value. So see how these go together? So if you've got a less than or equal to hypothesis, that's your claim here, that is your null. Your alternative is going to be the opposite. So see how this is less than or equal, and this one is greater than? These are the reverse. These are the opposites of each other. So for this one, you've got a greater than or equal to, so you're going to have a less than or equal to. And for here, if you have an equal to, then you're going to have a not equal to. For the different types of two sample hypothesis testing, you basically get the symbols the same. The only difference are the means. And for this one, I wouldn't really worry as much about the two sample because we're mostly going to be dealing with one sample for right now. But the biggest thing is realizing whatever your null is, the alternative is the opposite, or vice versa. If you're given an alternative, the null is the opposite. So when reading a statement, here are some keywords to look for to tell whether it's the null or alternative hypothesis. And the reason we're going through these is that you're going to have a quiz and a homework assignment. Your homework assignment, you're going to try to figure out whether something's the null or the alternative, and then state in your own words the opposite then. And then for your quiz, you'll have to be determining whether it's the null or alternative as well. So the null hypothesis, you can see an example is not related. So that means if you're reading through the claim, it would have something to say that's not related versus it is related. Are versus are not. Does not play a role, does play a role. No difference is a difference. Does not affect, does affect. Is not a factor, is a factor. So you can kind of see here are the kind of opposite flip words that you can help tell whether it's your null or alternative. So for example, if you've got a null hypothesis that says two things are equal, if you need to state the alternative, you would say that they're not equal. So that's just kind of are equal, are not equal. Now you can't mix and match. You can't say at least and is a factor. That's kind of not the same. You would want to actually say less than or equal, and then you use greater than, or at least and below. So you'd want to use ones that are kind of side by side to each other. So that is everything for our Chapter 2 hypothesis testing for just this week. Something else to be thinking about is types of errors. So regardless of which hypothesis represents the claim, you always begin a hypothesis test by assuming that the equality condition in the null hypothesis is true. So you're always assuming that the null hypothesis is true. And this is a really important statement. That's why it's italicized. You always begin a hypothesis test by assuming the equality condition in the null hypothesis is true. When performing a hypothesis test, you make one of two decisions. You're either going to reject the null hypothesis or retain the null hypothesis. Because our decision will be based on a sample rather than the entire population, there's a possibility that we can make the wrong decision. Because remember, we can't sample from every single person in the entire world. So we don't ever have, or rarely ever do you have an entire population. You're almost always dealing with a sample. And because you're almost always dealing with a sample, there's always a possibility that we make the wrong decision. So with that in mind, we have two types of error that can occur. A type 1 error is when the null hypothesis is rejected and it's actually true, and a type 2 error when the null hypothesis is retained when it's actually false. So possible outcomes of a hypothesis test. So remember, HO is your null hypothesis. So here it's saying the null hypothesis is not rejected and the null hypothesis is true. Okay, so that's the correct decision. So technically it's retained, so the null is retained, and the HO, the null, is true. So for here, the null is not rejected or is retained, but the null is false. That's your type 2 error. In this one, your null is rejected, so here we're saying nope to the null, and the null is false. And so you're saying, okay, that sounds good, that's a correct decision. But what happens if your null is rejected, but the null is true? That's your type 1 error. Here's an actual table. It's basically the same information that's right here above. It's just kind of, I don't know, it's in table format. So for me, I think it looks a little bit, easier to read. So the experiment conclusion, and so this means based on the data you rejected or retained, and the actual situation is either the null is true or the null is false. So something else to think and just kind of keep into consideration is also alpha. In scientific research, we typically take a conservative approach and set our criteria such that we try to minimize the chance of making a type 1 error. So there's your type 1 error, concluding that there is an effect of something when there really isn't. So in other words, scientists focus on setting an acceptable alpha level or level of significance. So what this basically is doing is trying to say, I'm only willing to have this percentage, which we'll kind of get to, which normally is 0.05, chance of making a type 1 error. So you can lessen that. So sometimes people might say 0.01 or something like that. But the more or the less you have of making a type 1 error, the more likely you are to make a type 2 error. So that's where you kind of have to pick and choose which error you would rather make, or which error is worse. So the alpha level is a probability value that defines the very unlikely sample outcomes when the null hypothesis is true. Whenever an experiment produces very unlikely data, as defined by alpha, we will reject the null hypothesis. Thus, the alpha level also defines the probability of a type 1 error. That is the probability of rejecting the null when it's actually true. In most cases, alpha is set to 0.05. So you might be wondering, throughout the semester, we are going to be comparing different statistical values that we get to 0.05, and this is why we actually compare them to 0.05. We're actually comparing them to this alpha level that we're setting because we're trying to minimize the chance of making a type 1 error. So that, I think, concludes just a little bit for this week. It should be able to get you through, though, your quiz and your homework. And if you have any questions, please let me know. Thank you.